Today I am going to discuss about the difference between capital G and small g. That means acceleration due to gravity small g and capital G gravitational constant. On the other side we are going to differentiate the mass and weight also. Okay, let's start. What are the differences between capital G and small g? This is a very confusing matter for the student, and these two are very different matter. That's why we have to remember all the time in different examination and in other sector also we have to deal with these two symbols. Capital G, it is the symbol for gravitational constant, but small g, it is the symbol for acceleration due to gravity. Now next we can say definition also. Gravitational force between two unit masses separated by a unit distance is called G, means gravitational constant. If two unit masses are separated by a unit distance, then what amount of force involves between them as gravitational force, that is taken as capital G. But acceleration due to gravity is acceleration developed on a freely falling body due to the gravity of the earth is called small g. Freely falling body, it means the body should fall in vacuum, and then only we can say that its acceleration is acceleration due to gravity. Okay, now next difference. Its value is 6.67 into 10 to the power minus 11 Newton meter square by kg square. But its standard value is 9.8 meter per second square. We have to use this value in numerical problem frequently. Now, it is a scalar quantity. Which one? Capital Z. It is not the unidirectional physical quantity. That's why this is not a vector quantity. This is a scalar quantity. But G, it is a vector quantity because its direction is towards the center of the earth. Okay, next. Its value remains constant throughout the universe because it is actually the gravitational force between two unit masses, and it remains same whether we are in space or we are on the earth. But its value varies from place to place of the earth. These are the basic differences between capital G and small g. One is vector, another is scalar, and value is also different, and they are defined differently. The differences between mass and weight. What are the basic differences between mass and weight? First, we can say definition. Quantity of matter contained in a body is called mass of the body. If quantity of matter is more, then mass will be more, and quantity of matter is less, mass will be less. A big stone has more quantity of matter than a small stone. That's why big stone has greater mass than that of the small stone. But what is weight? The force with which earth attracts a body towards its center is called weight of that body. It means the weight of a pen is the force of attraction of the earth acting on that pen. Weight of a man is the force of attraction acting on that man. This is the basic difference between mass and weight according to definition. Okay, let's go to another point. It is measured by using physical balance, but the weight is measured by using spring balance. It is a scalar quantity. It has no any definite direction. We cannot expect the quantity of matter has direction. But weight, it is a vector quantity. Its direction is towards the center of the earth, and its value remains same at any place of the earth. But weight, its value varies from place to place of the earth. And mass, its SI unit is kilogram, but the SI unit of weight is Newton. These are the basic differences between mass and weight. Let's go forward. Mass of the body cannot be measured in space. This is very interesting matter. We are using a physical balance to measure mass of the body. Let's say it has two pans and a beam is attached with it. If a weight is taken in one of the pan, then this side goes down in the space. If the unknown mass is taken in another pan to measure its mass, then this pan then goes down. It means a little amount of force when applied on the pan, that pan goes down. We will not be able to measure the mass. Look at this. If we put a standard mass in one of the pan, if we make the beam equilibrium, then it remains equilibrium. What it means? Without the unknown mass, only standard mass is placed in one of the pan, but the beam of the balance is in equilibrium. And if we take the unknown mass in one of the pan, and if we hold the beam, and if we try to make it balance, then it will be balanced again. What is the meaning? Meaning is very simple. Actually, weight of a body is measured by using gravity force of the earth. When gravity force of the earth acting on the standard mass is equal with the gravity force of the earth acting on the unknown mass, then the beam of the balance comes in equilibrium. And we used to say that this unknown mass is equivalent with this standard mass, maybe 1 kg or 2 kg. But in space there is nothing, I mean to say, no any attraction force. The gravity force of the earth is missing and other attraction force is also missing. That's why we cannot measure mass in the universe. That's why we cannot measure mass in the space. Okay, we can write this way. Mass of a body is measured by using beam balance and is measured by comparing gravitational force acting on an unknown mass with the gravitational force acting on a standard mass. In the space, there is no gravitational force, so mass of the body cannot be measured in space. Okay, let's move to another. Weight. What is weight? We can say this way, the force with which the earth attracts a body towards its center is the weight of that body. This is the real definition of the weight. But there is another definition also. In terms of measurement, we can define this way also. Weight of a body is the product of its mass and acceleration due to gravity, and symbiotically W equal to mg. If we have mass of the body, then we can get its weight, because we know the acceleration due to gravity, its value is in average 9.8 meter per second square. That's why second definition is according to the measurement. Let's move forward. Weight depends upon mass and g. Certainly, we have seen just now, weight depends upon this mass m and acceleration due to gravity g. But how? Let's say this is a small stone, this is a big stone or big mass. Small stone has less mass, but big stone has more mass. Both of them are attracted by the earth. And the attraction force of the earth acting on these two masses depends upon what? Their mass and acceleration due to gravity g. G at a place remains same, but mass of these two bodies are different. That's why the bigger one is pulled by more weight, because its mass is more. That's why product of mass and g will be more. That means weight is more. But in case of a small mass, less mass, what happens? The pulling force of the earth acting on the body will be less, because mass is less, g is same. We can say that weight of a body is directly proportional to its mass. Okay, this can be understood this way. Weight of a body is the product of its mass and acceleration due to gravity, W equal to mg. G remains same at a place, but mass of big stone is greater than the small stone. So the product of mass and g, that is weight of the big stone, will be more than the small stone. Weight is more at pole than the equator. Why? We can say this way, weight of a body is the product of the mass and small g, that is W equal to mg. We can say this first. And mass of the body is constant, but g is inversely proportional to the square of the radius of the earth. It was done in previous class also, we proved this. Earth's radius is less at pole than equator, so g is more at pole, and the product of mass and g, that is the weight, is also more at pole. Let's move to another. Weight is more at the top than the bottom of the mountain. Why? This is one of the important questions frequently asked in examinations. Okay, we can say that this way. This is, let's say, earth, and there is mountain at certain place. Let's say this is mountain, and radius of the earth is less up to the bottom of the mountain, but it is more at the top of the mountain. And we know that acceleration due to gravity small g is inversely proportional to the square of the radius. It means radius is more at the top. That's why g is less. And weight of the body is the product of mass and g. So it is less at the top of the mountain. We can answer this way. Weight of a body is the product of its mass and g. And W equal to mg we can write mathematically. Mass of the body is constant, but g is inversely proportional to the square of the radius of the earth. Earth's radius is more at the top of the mountain than the bottom, so g is less at the top, and the product of g and mass, that is the weight of the body, will also be less at the top of the mountain. It means weight is less. This way we can answer. Look at these are very important question which I am going to present, and I want to tell you answer also in the same way. Weight of the body varies from place to place of the earth. Weight of a body is the product of its mass and acceleration due to gravity. We are doing this from the beginning. W equal to mg. And Earth's radius is different in different parts of the earth because earth is flat in at pole and bulge at the equator. If radius is less at a place, then g will be more. And radius is if more at a place, then g will be less. And the product of mass and g depends upon what? It depends upon g. The value of g is if more, then weight will be more, and value of g is if less, weight will be less. That's why g varies from place to place, and weight of the body also varies from place to place. Okay, next, weight of a body is more at sea level than other places. Weight is the product of m and g, and g is inversely proportional to square of the radius of the earth. Earth's radius is minimum at sea level, so g is maximum, and the product of maximum g and mass of the body, that is weight, will also be more at sea level. This way we can answer this question. Okay, I think I told you about the mass and weight, and I told you about the capital G and small g also. Okay, now I want to stop here. We'll meet in next class. Thank you.